Hi friends, this is Prashant. Today we are going to start with Upthrust Part B Numericals. Chalo, let's start. First numerical Part B. Part B. Right. The density of copper is given as 8.83 gram per centimeter cube. Expressed in kilogram per meter cube. Now since we know that 1 gram per centimeter cube, 1 gram is 10 raised to minus 3 kg, and this is centimeter cube, means 10 raised to minus 6 meter cube. Now from where you got, we have 1 centimeter is 10 raised to minus 2 meter. इसका cube, the whole term का cube, 10 raised to minus 6 meter. So this comes out to be 10 raised to 3 kilogram per meter. So I can write here, therefore density of substance is 8.83 into 10 raised to 3 kilogram per meter cube. This is your first numerical. Right? Check the next one. Second numerical. In second numerical, what is given? Relative density of mercury is given, that is Rd is given as 14.6. State the density in CGS and in SI. So that here in CGS, density of substance is equal to Rd. What is the value? 13.6, which will be gram per centimeter cube. And in second, what is given? In SI, density of substance is equal to Rd into 10 raised to 3. So this is equal to 13.6 into 10 raised to 3 kilogram per meter cube. This is second. Third numerical, what is given? Density of ion, which density of solid is given 7.8 into 10 raised to 3 kilogram per meter cube. What is its relative density? Rd they want. So we have Rd is equal to density of substance upon density of water at 4 degrees Celsius. This is equal to density of substance is 7.8 10 raised to 3 upon 10 raised to 3. This get cancelled. 7.8 is our answer. It has no unit since it is the ratio of two similar quantities. Check with the fourth one. Check with the fourth numerical. Relative density of silver is given as 10.8. Means what is given? Rd is given as 10.8. Find its density. So right here, density of substance is quotient. But since we know that density of substance is equal to, it is Rd into 10 raised to 3, that way I can write this is 10.8 into 10 raised to 3 kilogram per meter cube. This is SI. Check the fifth question. What is given? A mass of body whose volume V is given as 2 meter cube. Rd is given as 0.52 and they want mass. Right? First of all, Rd is equal to density of substance on density of water at 4 degrees Celsius. So I can write here density of substance is equal to Rd into 10 raised to 3. So 0.52 into 10 raised to 3 kilogram per meter cube, which is the density of substance. Now since we know that density of substance is mass upon its volume, so I can write here mass of body is volume into density of substance. This is 2 into 0.52 into 10 raised to 3. If you multiply, this comes out to be 10, which is 1040 kg. That will be the mass of the body. Right? Check the next one, 6th one. what is given in sixth. In sixth question, calculate the mass. Okay, mass is question now. Volume of the body is given, that is volume of container is 4.5 into 3.5 into 2.5 meter cube. Density is given as 1.3 kilogram per meter. NTP is normal temperature pressure, that is your atmospheric pressure, regular temperature, room temperature. Now, since we know that the density is mass upon its volume, this mass is equal to volume into density of substance. Volume will be 4.5 into 3.5 into 2.5 multiplied by 1.3. That gives out to be 51.19 kg. This is the mass of the body. Check the seventh one. What is given? A piece of stone of mass 113 gram. Mass is given 113 gram. Sink to the bottom in a water containing a measuring cylinder, and water level rises from. So volume of body is equal to increase in level. Increase in level, right? Which is equal to, it is V2 minus V1. It is given as 10 ml. It is 40 minus 30, which is 10 ml. Now, since density of substance is mass upon its volume, mass is 113 upon 10, which is 11.3, and therefore density of RD is equal to density of substance upon density of water at 4 degrees Celsius, which is 11.3 upon 1, 11.3, no unit is the ratio, right? Now check the eighth one. What is given in eighth? Eighth means what is given? A body of volume 100 centimeter cube. Volume is given as 100 centimeter cube capacities. Weight in air W1 is given as 1 kgf, which is equal to 1000 gf. That is weight in air. Find its weight in water and RD. W2 they want and they want RD, right? So first of all, this is water. The density of liquid is 1 gram per centimeter cube. Since we know that the upthrust FB is equal to volume of the body, density of liquid into G. Volume is given as 100, density of liquid is 1 into G. This is 100 G, right? That is upthrust. Therefore, I can write here W2 is equal to W1 minus your upthrust. This is equal to 1000 minus 100. That is equal to 900 G. That is weight of body in water. Now, next is RD they want. So, since we have RD is equal to W1 upon W1 minus W. So, this is your 1000. This is 1000 minus 100, like 900. That comes out to be 10. So RD will be 10. Right? This is about the 8th question. This is about the 8th. Now we'll go with 9th. This 8th question is important. See, rather 8th onwards, all numericals are important. Check the 9th one. A body of mass 70 kg. Right? What is given? Mass 70 kg. So can I write here therefore weight in air is m into g, which is 70 kgf. Displaces 20,000 centimeter cube of water. So volume of body is equal to volume of liquid displaced. So what is the volume of liquid displaced? It is 20 into 10 raised to 3 centimeter cube. You have to convert this into meter cube. So this is 20 into 10 raised to 3 into 10 raised to minus 6, which is 20 into 10 raised to minus 3 meter cube. You have the volume. find the weight of body in water and RD pressure. So first of all, get the value of upthrust. Upthrust is volume of the body, density of liquid into G. Volume of body is what? 20 into 10 raised to minus 3. Density of liquid is 10 raised to 3 into G. So this is 20 into G, which is written as 20 kgf. That is the upthrust. Therefore, weight in water W2 is equal to W1 minus this upthrust. This W1 is 70 minus 20. This is given as 50 kgf. That is weight in water. And next part they want RD. So RD is equal to W1 upon W1 minus W2. W1 is 70. W1 is 70 minus 50. That if you solve this, you will get something. I think it is 3.5. Answer will be 3.5. Right? This is about 9. Now check the next sum. 10th. In 10th sum, a solid weighs 120 gf in air. That is W1 is given is 120 gf. W2 is given as 105 gf. It is 105 gf. Find the relative density of solid RD to know. So we have RD is equal to W1 upon W1 minus W2. We will get something like. Now check the 11th one. 11th is different. A solid weighs 32 gf in air. W1 is given as 32 gf. And W2 is given as 28.8 gf. That is weight in water. Find the volume of solid, RD of solid, and weight of solid in a density of liquid. Density of liquid is given is 0.9 gram per centimeter cube. Density of water is 1 gram per centimeter cube. Right? They want weight of solid in liquid. Okay. The first part means, like here, upthrust in water is equal to W1 minus W, that is loss in weight. Loss in weight, it is 32 minus 28.8, which is equal to 3.2 gf. This is what 3.2 gf. Now since we know that upthrust is equal to volume into density of water into G. It is written as 3.2 into G. Volume of the body, density of liquid is water is 1 into G. I can cancel this VV or GG. We get volume as 3.2 centimeter cube. This is our first answer. Now next what they want, find the RD of solid. So like here RD of solid, it is equal to RD of solid is W1 upon W1 minus W. Everything is given, we did the answer. Now they want weight of solid in liquid of density. So we will write here third part में upthrust in liquid or upthrust due to liquid, right? So is equal to volume of the body, density of liquid into G. Right? I can say upthrust in liquid. So this is volume is 3.2, this is 0.9 into G. So this comes out to be something GF, right? Then next part, therefore weight in liquid is equal to W1 minus upthrust in liquid. Right? If you solve this, you will get something GF. That is your answer. Right? Now come to question number 12. Question number 12. In question number 12, what is given? A body weighs 20 gf in air. But W1 is given 20 gf, that is weight in air. 18 gf in water, W2 is given as 18 gf. Right? Calculate the RD. RD is equal to W1 upon W1 minus W2. It's going to be something. Right? This is 12. 13 question. A solid weighs 1.5 kgf in air. That is W1 13.5. So it is given as 1.5 gf is in here. Density of liquid, this is weight in water, 0.9 kgf. This is kgf. This is also kgf. Density of liquid is given is 1.2 into 10 raised to 3 kilogram per meter. Calculate RD of solid. So for this, first get the value RD of liquid is equal to density of liquid upon density of water at 4 degrees Celsius. This is equal to 1.2 into 10 raised to 3 upon 10 raised to 3, they get cancelled. 1.2 is the RD of liquid. So I can write here therefore RD of solid is equal to W1 upon W1 minus W2 into RD of liquid. Right? You will get something is the answer. Now we'll go with 14th one. What is given in 14th? 14th is very important sum. Numbers are very complicated, but numericals is very easy. Now what the question says, if you are a jeweler, right, you are purchasing say gold ornaments from a jeweler. Now say that person is not trustworthy. The person from where you are purchasing this gold is not trustworthy. So he claimed that he makes an ornament of pure gold of relative density 19.6. So I will write here RD1 of gold as per jeweler, because jeweler claims that my jewelry is of 19.3, that is the relative density of that gold, pure gold. Now he sells a bangle weighing 25.25 gf, that is weight in air is 25.25 gf. This is weight of bangle in air. The clever customer weighs the bangle when immersed in water and find its weight. Its weight in water is 23.075 gf. This is weight in water. Now with the help of suitable calculation, find out whether the ornament is made of pure gold or not. By this calculation, find the RD2 of gold, which is question mark. Now I will write here, since RD2 is equal to W1 upon W1 minus W2. Now W1 is your 25.25 upon this is 25.25 minus 23.07. If you solve this part, this comes out to be 11.6, right? Now since your RD1 is greater than your RD2, therefore gold is not pure. If these two values are remain same, मतलब RD as per jeweler and your calculated value अगर same है, then you can say that this gold is pure. Now since these are two values are different and this is less, therefore gold is what? Impure. Gold is what? Impure. Right? This is 14. Check the next one. Next one, what is given? A piece of iron weighs 44.5 gf in air. That is weight in air, which is 44.5 gf. This is weight in air. Density of iron, the density of solid is given, which is 8.9 10 raised to 3 kilogram per meter cube. Right? This is the density of iron. And find the weight of iron is in water. Right? So first of all, what we will do, I will write RD of solid, right, which is equal to density of solid upon density of water at 4 degrees Celsius, which is equal to, this is equal to your 8.9 10 raised to 3 upon 10 raised to 3. This value get cancelled, 8.9. Now we have, since WRD is equal to, it is W1 upon W1 minus W2, right? So if you substitute the value, this is 8.9, W1 is 44.5, this is 44.5 minus W2. If you solve this comes out to be W2 is 39.5 GF. In textbook, this answer is given as GM, which is wrong. It should be GF, right? And we'll go with the last sum, right? That is 16. Check. In 16, what is given? Here, piece of stone of mass is given as 15.1 gram. So, can I write here therefore directly weight in air is m into g, which is 15.1 into g, which is 15.1 gf, that is weight in air. Immerse in a liquid of, that is W2, weight in water, this is in liquid, which is 10.9 gf, weight in water, 42. And then it is immersed in a water, so W3 is given, which is 9.7 gf. This is your weight in air. This is weight in liquid. And this is your weight in water. This is weight in what? Water. Find the weight of piece of stone in air. This is your A part, which is given. Volume of piece of stone. So we write here B part. Upthrust is equal to loss in weight. It is nothing but loss in weight. What is loss in weight? That is W1 minus W3. That is loss in air, or the weight in air minus weight in water. Here this is given as 15.1 minus 9.7. This comes out to be 5.4 GF. This is 5.4 GF. Now since we know that the upthrust is equal to volume into density of water into G. This is 5.4 into G से multiply करूँगा because ये GF है, which is nothing but multiplication by G. Volume as it is, density of water is 1 into G. G cancel 1. So I can write volume is 5.4 centimeter cube. This is the second. Now RD of solid they want. So RD of solid is what? This is RD is equal to W1 upon W1 minus W3. But W3, why W3? Because weight in water. That is RD of, this is solid. Now we will get something value. Then D part, what is the RD of liquid? So that your RD of liquid is equal to W1 minus W2 upon W1 minus W2. You substitute the value, you get final answer as 0.78. Right? Now that's it for this video. Please do subscribe my channel so that you will get more videos for 9th standard. Thank you so much.